Hello and welcome to the November update from the Tau team. You're here with me, Fola, and let's get into your Q&A questions. All right. The first question is from Dana, and he asks, can Tau language be extended to support specification of decentralized business models or game theory from discussion requirements?
Yes, of course, it all depends which games and which models. Some of them for sure yes, some of them for sure no. Just because they fall under this category doesn't mean that that doesn't say anything on whether they can be expressed in the Tau language or any language. But I can say that Tau is able to cover a very wide range comparing to other languages of, let's say, business models and games.
All right, fantastic. And the next question is from John, and he asks, hi team, just wondering when the winners of the community contest Tell Us What You Love Most About TauNet will be released. Cheers.
Yes, so the winners have recently been contacted, and I've basically sent them their payment or their rewards for winning. And yeah, thank you all for participating. There were like lots of good answers. I think we had like 5 winners, and yeah, we've privately messaged them. Thank you.
All right, the next question is from Sir Andrew, and he asks, for the layman, good splitters are for refining and bad splitters are for expanding, and strong normalization ensures the resulting logical formulas are sound. Would you agree?
Thank you for the question. So a splitter of a formula is basically a formula with some additional assumptions added to it. And now a good or a bad splitter, they both mean that we added assumptions to the formula, but they differ in the way that we did it. So in layman terms, I guess, when you add information to the formula that is meaningful to the formula itself, we call it a good splitter. And if you add, let's say, artificial assumptions to the formula, then it is a bad splitter. More logical terms, the Tau language, we have uninterpreted constant symbols. And whenever we cannot find a way to add more assumptions to a formula, we take a new uninterpreted constant symbol and assume that is equal to 0 or unequal to 0, for example. And then this we add to the formula, and therefore adding an assumption. But in a sense, the splitter doesn't say anything related to the formula. This is why I said earlier that this is a bit artificial and not necessarily meaningful to what the formula says, but logically correct. Now turning to the strong normalization algorithm, it basically is a pre-processing step on the formula such that it is easier to decide how to add an additional assumption. So after a formula has run through the strong normalization process, we can be sure that adding certain assumption is actually really adding assumptions and not just adding information that is implied by the formula already. And for this reason, the strong normalization is a pre-processing step that eases splitter computation. I think that's a good way to view it.
All right, fantastic. And the next question again is from Sir Andrew, and he asks, what does the less than and greater than symbols mean for Tau language?
Thank you for the question. So in general, less or greater, for example, also on the integers, when you say 3 is less than 5 or something like that, in mathematical terms, this symbol is called a strict partial order. And on a Boolean algebra, you can define a strict partial order in general. And the way to visualize this is to embed the Boolean algebra into a collection of sets. So by Stone's representation theorem, we know that every Boolean algebra can be embedded in a collection of sets, and then the less relation exactly describes the subset relations of those sets. So basically, when you have that one Boolean algebra element is less than another, this translates to, when you embed the Boolean algebra elements in their respective sets, that the one set is contained in the other. This is what the less means on a Boolean algebra, and similarly the greater is the superset relation when you embed the Boolean algebra into a family of sets. To give a concrete example, you can take, for example, the Boolean algebra of propositional statements, and then when a statement A implies a statement B, you can also write this as that the statement A is smaller than the statement B, though in this case it's smaller equal, so maybe it's not, in this case it's smaller equal.
And this question is from Inevitable, and they ask, when can we expect a demo for the non-technical members of the community? Also, how long until testnet?
Thank you for asking the question. As you can see, Tau is a highly technical language, but we're working on making it easier to use and easier to comprehend. Perhaps in a couple of weeks, as soon as we're finished fixing some of these urgent issues that we have around the release efforts, Ohad might be able to put together an easy demo that anybody could understand. Anybody with, I would say, some minimal knowledge of logic should be able to understand. As far as testnet is concerned, now that we're wrapped up the first release of the Tau language, we'll be focusing on testnet next, and our goal is to have a first release of testnet by Q2 of 2025.
All right, fantastic. Thanks, Karim. And the next question is from Sir Andrew, and he asks, what are global operators on Tau language?
Thank you for the question. So the two global operators in the Tau language are currently the sometimes and the always keyword. Though I wouldn't necessarily call them operators, but really they are quantifiers at the moment, and they quantify the time point. So the always keyword quantifies the time points universally, and the sometimes statement quantifies the time points existentially. So this is why we say that an always statement is true at all time points, and the sometimes statement just has to be true at a single point in time. And now why are we calling them global? This is just terminology to express that they talk about the entire timeline, because the existential, so the sometimes has to know the entire timeline in order to decide when is it the case, and the always straightforward talks about every time point, so it's also talking about the entire timeline. And this is why we call them global. Local, on the other hand, would be something that belongs into one particular step. So as long as you talk about everything that is the case at time t, so where t is still a free variable, then we say that this is like local statements, because they can't talk about the entire timeline, but just locally about the time point t.
All right, fantastic, thanks. And the next question is from Matthaus, and he says, hi team, are there any significant bugs in Tau language?
Yeah, so yes, there are still significant bugs which we fix right now. And for such a demo, so first, this capability already exists. Tau can already do things that LLMs cannot do. But to design a demo that's of this specific thing, that's a non-trivial task, and we will have to think how to do it. Yeah, so the demo that I want to do is to write a Tau program that accepts commands from the user. And each command is basically a software update, right? So the user tells the system how to change its behavior.
All right, fantastic. Thanks, Ahad. And the next question from Matthaus is, hello, TauNet team. How confident is the team in delivering the Tau blockchain testnet by 2025? So as Karim mentioned, we're looking at Q2 2025, not by 2025. So we're looking at Q2 2025. Cheers. And this next question is from Logic Seeker, and they ask, how does Tau language ensure correct by construction software?
So correct software means that the software admits its requirements. And in Tau, you write only the requirements, and the system automatically generates a program from the requirement. So by construction, it is correct. It meets its requirements. If I understand correctly, you ask what is required in order to compile the code of the Tau language. And the answer is that you need a standard C++ compiler, and you need the standard Boost libraries and the CMake, which is also a standard tool in common tool chains. And I don't know what it means to support advanced logical frameworks, but one way virtually any other logical framework is supported is by recalling that the Tau language is not one language really, it's really a language extension mechanism. And you can plug into the Tau language other languages as long as you have implementation of the logical framework that they require, and the Tau language will be able to use them and reason over sentences in those languages, even in a temporal fashion. So, for example, a sequence of sentences over time.
And this next question is from Sir Andrew, and he asks, do you have a strategic plan on how to accurately implement the TauNet provisional patent where certifying entities are needed to certify user credentials? How can the community help?
The business plan and the basic operating mode of the certifying entities is they need to be independent of us. We will probably implement a first certifying entity, but we want to see people start their own certifying entity just so they can remain completely independent from us. So that's how the community can help possibly.
All right. And the last question is, will scaling discussions be included in the full demo of fully user-controlled blockchain? Is this before, during, or after TestNet? Thank you.
Yeah, definitely after TestNet. So TestNet will be the basic blockchain. Then we'll add implemented in the Tau language. Then we'll add user control, and after that we'll add scaling discussions. So that's the progression that we're planning.
All right, fantastic. Thank you to all of you guys for tuning in, and yeah, we'll see you in the Telegram and our usual socials. Cheers.